Okay, welcome to Group A demo. This is the final solution for the secret key guesser. Uh, for this solution, we are implementing a data structure. A custom data structure is the custom hash map. In this hash map, it is designed to only hold 5 maximum entries to the entries array. So there are two standard method for a hash map, which are the put and the get method. The put method is used to create new entry to the array. So if the key is no, then we'll create a new value. If there are collision, we use linked list to resolve the collision. If the key already exists, we'll update the value. So the get method is to retrieve the value of the key. So that's basically it. That's basically the custom hash map. So back to the solution, there are two steps in our algorithm. One is this is the initial guess, and then we have the refined guessing. So what's the initial guess? We want to count the present of each unique character in the string. So we do this by of running a loop, and we count only for the four first character, and the last one we use math to calculate it. Here, this is how we use math to calculate the last value. So if one of them is 12, then we know is the if one of them is 12, then we want to stop the algorithm. So, but why why guessing why doing the initial guess? We want to keep track of the maximum value as well, which could be used in the later process. So here we put every key in with their value in the hash map, and next we start with the next guessing. So we want to use the string here. For example, this one, we want to use the initial string with the maximum count because it will increase the chance of guessing correctly with our algorithm. So we start a loop that can go up to 5 loops with every index. We loop through every unique characters in this order, and if their count in the hash map is 0, then we want to ignore it. Or if that character is the same as the initial my guess, then we want to ignore it as well. And then we start guessing, and we replace the index with that character, and then we start guessing. So here we want to keep track of the change in the guess guess count. So if the new guess count is larger than the current guess count, then we know that that new character is in the correct position. But if that one is lower, then we know the old key, the old value and the old characters. Yeah, then we know the old character is the correct one. Uh, so that's basically the algorithm. We want to continue it until the end of the string. So this is how we visualize it. That's like slow. So here we have initial guess. We have 5 guess. Then we make 4 guess. So the last one we use math. So yeah, and we pick the largest one. So this one H appear first. So we use H. And set the initial guess to H. So we put everything else in the table in the hash map. After that, we can start looping. We start a loop. The next one with the table start with M. So we replace first with this one character, and we keep track of changes. You see, there's no change, so we continue. There's no change as well, so we continue. And there's no, oh, there is change now. So we see when we replace with C and the count increase, then we know C is correct. So we update this value to C and continue to the next one. So continue to the until the last element. We see H, M. We replace H with M. The value decrease. The decrease we see before we see 4, but now we see 3. Then it's decreased. Then we know H is correct. So we update it. and continue with index, and we continue it. Here we will skip age because we are not guessing with this value because the inner string is age, so it would not make sense if we guess age again. It would not change. It's guaranteed to not change, so we skip it. So we continue to A. Oh, we see A. The new value is higher, so we know A is correct. Like that again. So we continue. Oh, M is correct. We see new. So we will continue it toward the end. Yeah, we see the guest count, and we find guest count is 22. So this is our final solution. Thank you for watching.